Good morning everybody, and welcome to this repeat of last week's webinar regarding what's new in SolidCAM 2016 part 2. If you saw the webinar yesterday, you'll probably remember that I mentioned that today I shall be doing a few demonstrations of the more major features that we included in SolidCAM. We have included rather in SolidCAM 2016. The major enhancements being the advanced mill turn solutions, which I described briefly as a bit of a catch-all term for all of the enhancements that have been added in the mill turn modules, because together all of these enhancements provide you with a solution, a mill turn solution for the various types of complex mill turn machines they are, whether they're a single turret, single spindle type machine, or multiple turrets, tilting turrets with a B-axis, twin spindles, etc., etc. You know, we can have numerous axes, 11 axes, 12 axes, whatever it is it's got on these machines. We can control it in SolidCAM, and we've advanced our mill turns setup, if you like, to take this into consideration. Let me just, I'm getting a warning on my computer that my battery is low for some reason. It's plugged in. If you lose me, that's why. I don't know what's going on. I'm getting a warning on my, oh dear, Friday, it's weekend, isn't it? Okay, we'll see how we get on. If I disappear, that's why. Yeah, something strangely wrong there. I think it might be just my batteries actually on its way out. Anyway, I digress. Right, okay, let's carry on. In this webinar, as I say, we'll be looking at the major changes and improvements in SolidCAM 2016. I shall be doing demonstrations on these. So it's going to be a reasonably longish webinar this morning. It'll be 40 minutes or so if I can stop waffling on too much. So what we've got as well as the advanced mill turn solution to show you is the interactive machine preview, which is also included on the mill turn. We've got the combined operations in iMachining as an additional feature in 2016. I'll not go into any detail about that, except that it's pretty straightforward. You can just combine your finishing operation with your roughing operation if you're using the same tool, for instance. One thing I will be showing you is the active feature avoidance in the iMachining 3D, which is an excellent addition, I think, because it's something that's it's been required, I think, for a while, and we've added it in. Basically, you select your fixture in your setup. You tell it that you want to avoid it by a certain amount, and it does it just straightforward. No messing about. It's quite good, and it's very good, in fact. And also we have an addition of mirroring operations on a plane or a coordinate system. Now this is particularly handy if you've got left-hand, right-handed versions of a part. You know, you can machine one version of a part and then apply the toolpath in a mirrored fashion to another component, and then you have a second program from that, which I'll be showing you briefly at the end of the webinar. I've just added it on to the end of this webinar. I didn't include it last time, but I've added it in this time. Okay, so other improvements. If you didn't attend yesterday, I'll just briefly mention that in yesterday's webinar we showed the variable depths in the milling profile strategy that's been added in 16. We've also got various levels in pocket, meaning you can have a different start height and a different finish height. We also have various methods to select your geometry quicker, and you can mirror your toolpath around different axes in HSS and 5 axis, so you can mirror toolpath around the x-axis or the y-axis or whatever. And we've also got drill point removal in iMachining 2D, meaning that if you've done a pre-drilling operation, so that you can then drop down into that hole with your cutter rather than helically milling down there, you could always do that anyway, but if you are doing that, you can now the iMachining will automatically remove the drill point if there's any material left there. it'll automatically remove it. So I can briefly show you that today as well. Okay, so let's get cracking. Oh, before I continue, by the way, as I mentioned yesterday, I'll just remind you, what I'm going to show you today is just not so much a taster, it's just as much as I can cram into 40 minutes of webinar without trying to bore you to death and have your attention wandering, so to speak. So what we are hoping to do, because of the amount of changes that have been made in 2016, the amount of additional value enhancements, etc., etc., etc. There's been over 80 of these, and to cover them in webinar is going to be long-winded and boring. So we are running a series of one-day courses, training courses, on just covering the enhancements and additional modules and little things that have been included in 16. And if you do want to, you fancy joining one of these one-day sessions, if you contact Louise at SolidCAMUK.com or call the office, I'll put a slide up at the end of the webinar so that you can see the details required, and you can check on the price and availability of these little one-day courses that we're running. I'd recommend doing it because there's plenty of people who have bought SolidCAM and have had SolidCAM for years, and they perhaps aren't aware of all these little tricks and what have you that have been added over the years, and so it's good from that point of view as well, I think. Okay, what we're going to have a look at then is what's been added in the mill turn solution, all the different things that add up to what we now call a advanced mill turn solution. I'll be glossing over these a little bit because I'm going to be doing the demonstration anyway. So let's have a look at what we've got here. The first thing to notice is that the under the bonnet, you've got things that have changed that you don't sort of see in a day-to-day operational basis. But basically, in the VMID file, the virtual ID file that you may have seen, we've changed the way the machine is set up, the way it looks at itself, if you know what I mean. So it calculates things differently. So we've got devices on axes and not axes on devices, which is the way it was the other way around. And so now it's set up exactly as you would expect on an actual machine. So this now means that we can now see things in a different way. So we can have previews of machine STLs, devices where you've got stations and coordinates and kinematic axes. You can see them all in the VMID file if you ever go in there. The stock mounting, now you can preview that when you do your setup. You can tell it, you can decide whether where your stock is starting off. Is it in the front spindle, is it in the back spindle, or wherever it may be. You can have an interactive preview of any machine control operation that you may have, whether you've created it yourself, whether this is the one that we've created for you. There's you can see it being simulated on your screen there. You also have in the turning module, not just mill turns, in the turning module this as well, you've got more control over the gears that the machine may have. You've got several gear ranges. You can keep in gear ranges to a certain speed, and it'll automatically select the gear according to the spindle speed that you've selected. Interactive machine preview of the tool table, which I'll show you shortly. So you can now see the tools as they would be presented on the machine, in the holders, on the turret, in relation to other tools, in relation to the turret, in relation to everything else on the machine. So if you're looking at it on your screen as if you were looking at it through the window of the machine. So it's a lot more easy to see where things may cause problems perhaps. And what you've got, you can show each axis in a position where they are. So no need to select a previous machine operation to show where you currently are. You can just see it straight away where you're going to be. And what this all adds up to, as I say, is what we call our advanced mill turn solution, extended support of complex mill turn machines in all different stages, as you can see there. So we've got a few examples of different configurations of different types of machines. They're all mill turn machines, but as you can see, they are completely different style of machines. You know, what's a lathe and what's a milling machine these days? They all seem to merge into one thing, don't they? So there's a few examples of our graphic interface that you can see set up for different scenarios, different types of machines. So one thing, if you do have a mill turn machine, especially one with several turrets and several spindles, you may notice, well, you will notice that when you come to run your setup in 2016, you'll notice that you don't have as many Mach coordinate positions where you've got previously. You've got here in 2015 for the same machine, you've got 4 Mach coordinates relating to the upper turret and the front spindle and the upper turret and the back spindle, etc. Then the lower turret and the front spindle, the lower turret and the back spindle. 4 Mach positions. Whereas now in 2016 you only have the two coordinates, one for the front spindle, one for the back spindle. That's it. You don't need to separate the turrets out of there. It knows where these are, which is it's a lot easier to keep control of. Okay, before I move on to show you the mill turn solution, I'm just going to mention the channel synchronization, because it's part of it. It's within the whole scenario. So channel synchronization, nothing new. We've always had channel synchronization where you can time the different axes to do what they're doing, so that they're not in the same working space as each other at the same time and end up colliding with each other. You can move things about and time them accordingly. So we can now add an extra workpiece in the mill turn machine. So you've got a part in the front spindle and a part in the back spindle, and you can synchronize them so that the front turret's working on one while the back turret's working on the other. They're not in the same operational space as each other. So you can see that graphically. You can also, whilst you are working out which axis should be where at which time and which should be parked out of the way so it doesn't get in the way, you can see shows you possible clash points and where these might happen, and gives you a clue as to what's causing it, which is pretty handy. And once you've changed your sequence of operations in your channel synchronization, you can then simulate it in the actual order that you've put things. So it's just as it would be on the machine. So whilst you're running it in synchronization mode, you can see it in that way. All the other simulations will just show it in the CAM tree order. Okay, iMachining, that's next. What I'm going to do is flip my screen, hopefully to show you my my mill turn part. Let me just flip my screen for you so you can see that. Okay, hopefully now you can see my my mill turn part on in my SolidCAM window. Please tell me if you can't see this. Right, what I'm going to do here is quickly show you some of the features. I'm not going to do any actual machining. You can see it's already been defined. I'm just going to go through some of the menus here and see show you what's been added, things that I've mentioned earlier. So let's have a look at our setup first of all. Let's right at the very beginning. Let's see what our setup looks like. I'll just double click on that and open that up. And you can see it's pretty similar to how it has been, but bearing in mind this machine here is a twin turret, twin spindle machine, and as we see we've only got the 2 coordinates, and this both relate to the Mach 1 position rather than the Mach 1 and Mach 2 position. We've also got this little button here where we can show our stock, where it starts in the front spindle or the back spindle. We can decide where that is. We've also got this lovely little button here that you're going to love when you start using it in mill turn. It's called Machine Preview in this instance, so we'll click on that. Let's have a look. And here we do have our Machine Preview, as you can see. So this is our relationship between our upper and lower turret and our front and back spindle. We can also see that our stock is indeed in the front spindle as it's shown here. I can flip that back there into the back spindle and you can see it shows it in the back spindle, so you can see exactly where you are, and you can see that the coordinate follows it. So it's just a little preview, so you can see that everything is as expected. You've got your fixtures, your jaws, and your stock showing there. So that's exactly as you want to see it there. The other thing to show is the tool table. So if I go into the tool table here and double click on there, you can see that we have got all our tool libraries. We've got our upper turret tools and our lower turret tools there as normal, and you can see you've got your tool preview on the screen as always. What is new though is the way the mounting is. Same button, but you click on it, it opens up a completely different menu to before. We've got now much more information on this screen here. If I zoom in a little bit, it's the same as we were looking at earlier, except it's showing our tools rather than our part. There's no stock and there's no jaws on the spindles. We're interested in our tools here, so this is what it's showing us. There's the tool that happens to be in the turret. I think it's the first tool that's in the upper turret. If you look at the tool selected, that's the first tool that's in there already. The lower turret, this is a tilting B-axis milling and turning spindle that's on this particular machine. On the lower turret, you've got your standard turning turret as you would see on any machine really. And these tools are obviously mounted in the relative fixtures. So let's have a look at what we can do here. Here's our lower turret. That's our tool that's active at the moment. Tool 1 in that thing. Let's have a look at tool. What's that one? Tool 12. I don't know what. I can't see me tool numbering. But if I flick through the tools, you'll see the turret indexes, and you can see exactly where your tool is and where all your other tools end up being when that tool is selected. So you're going to be able to see, for instance, if I choose one of the tools up here, you're going to be able to see how far your other tools are sticking out, and whether there's likely to be any potential clashes between them just by indexing your tool around at this point. Let's have a look at something else that the tool active tool library will show you. Let's have a look at an operation. Here's a operation. I'm going on to the upper back turret, and I've picked the very first operation there, the face turning operation. If I open that operation, and whilst imagine we're just programming this, we might think to ourselves, well, let's see where I am here. You've got this option of machine view. This is as in all of the strategies, of course. So if I click on machine view, I get the option now to see where I am and where everything else is in relation to what I'm doing. So we've got the upper turret nicely in position, ready to do our first operation, which is the facing off operation. Must admit, I don't think I'd do it with that tool, to be honest, but there it is. And I'm trying not to move the screen around too much, but you can see the other turrets parked up out of the way, out of anyone's harm. Let's zoom up on the tool in question. On the part, we've got the part in the sub spindle. All the previous operations that have been done on the main spindle should have been done by now. You would expect to see them on there, and we can't see them. So we've got the option to update things. We can update the stock, and there we go. It's updated to show all the previous operations that were done on the previous on the front spindle. Let's have a look at something else now. Excuse me a second. I'm just trying to. Yeah, I think that's pretty much covered it on the mill turn side of things. Let me just look at some iMachining now. I'm just going to flip back to the other screen on my slideshow screen, and whilst I do that, I'm going to change my. Oops, God dear. Bear with me a second. I'm just trying to arrange my screen on the other screen that you can't see. Okay. Right. Tools. Come on. Bear with me a second. It's really difficult sometimes working with two screens when half of your programs you're running cover the other ones. Okay. Right. iMachining. Sorry about that. Just got to get me housework in order. New features in iMachining that I'm going to cover today include the what we've got here, optimized finishing of 2.5D features. So you can finish in iMachining for something that you've done previously, and it'll automatically hold off the walls, for instance, when it's finishing the floor, and vice versa. Automatic removal of the material left by a pre-drilled tip. So if you've got a 180-degree drill that you've been and used a pre-drilling hole for, you can automatically remove it using the 2.5D. And also the fixture avoidance that I mentioned earlier on. And we have the combined technologies where you can now include your finishing operation with your roofing operation. And you can finish after finish, so you can do you can roof and finish, and that can be your semi-finish operation, and then you can do a full finishing operation as well. Another thing that's been added in iMachining 2D is the choice of floor finish. You can now finish the floor in iMachining, and you can choose what style the finish you're going to end up on there. You can have the iMachining strategy itself, where you will end up with perhaps the morphing spirals showing on your tool path if you're familiar with if you use iMachining, or you can have the traditional normal standard step over of contour finish on your floor. Okay, let's have a look at some stuff here now. We'll have a look at the fixture avoidance strategy, for instance, and I'm now going to swap you over to my other screen. Okay, this operation I'm going to cover here is actually the drill point removal. This is a quick one. Say we've got a drill point strategy that we've previously done. So there's my drilling operation. I'm now going to then use that operation in my iMachining operation here, where I've chosen the drilling operation as my pre-drilling strategy, so that I'm going to drop straight into that hole. This is included anyway. This is already there in iMachining. But the difference here is that it takes care of the tool tip as well. So if I'm going to simulate this particular operation, I'll do it in Solid Verify, because it's a little bit easier to see, I think, in Solid Verify. If I tip that up, you can see indeed we've got a drill point on that part there. So all I'm going to do here is show you the tool. If I simulate this, you'll see the tool is indeed going to drop down there as it always would do, but now we've got the pre-strategy of it actually taking care of that tool point, that tool tip. It's removing that automatically for us without us having to worry about it. So you can see it taking care of that. Not had to do anything, not had to tell it anything. I've just had to choose the operation. It's automatically done that there, so there's no need to go much further in there. So that's showing you that nice and quickly. I'm just now then going to change to another part. Where am I? Oh, come on. Which one is it? It's that one, fixture avoidance. That's it. Here we have an example of a part that you may have clamped down. As you can see here, we've got several clamps here holding the billet down, and we're milling out this profile of this here part. So what I've done in our setup, we've defined our fixture as being the 4 clamps. Call it 4 clamps because it seems pretty obvious to call it that, and we can see which ones they are. So there's our 4 clamps that we've defined as our fixtures that we want to avoid here. You can have as much or as little on there as possible, of course. So when I open the 3D iMachining window up, the first thing on your page, on your geometry page, is the option as to whether you're going to use fixture collision protection or not. And then you've got a value that you can put in there as to how far you want to avoid that by. Obviously, if your fixtures are going to be, or your clamps or whatever, are going to be in a pretty accurately known position, then you can be pretty close to it. Otherwise, I'd give it a bit of a wider berth than 2 millimeters. And what this amounts to, if I click on the simulation mode here for you, I'll leave it on the host CAD so you can see it on the actual model itself. You'll see your tool comes down straight away, and it just mills around where the clamps are before it starts to then do what it would normally do. It's avoiding the clamps, starts in them areas, and then it carries on and does what it would normally do. So first thing it takes care of is the clear areas, as you can see, and then the next thing, once it's done that, it'll start actually going about its business and machining the part out, as it would anyway. So that's in advance. I'll speed this up a little bit so you can see what it's actually doing. So it's just going to mill all that material away as it would normally do in any 3D iMachining operation. But the first thing it's done is taking care of the area around the clamps, so that then it can clear that area and then work on the rest of the material. So that's an excellent feature for virtually no work. All you're doing is putting your clamp on there, telling it where it is, which ones you're using, and telling it how much you want to avoid it by, and that's it. It does it itself. It's just pretty damn good. Okay, that's fixture avoidance. Another thing I was going to just do a quickly demonstration on is the mirroring strategy that we have added into it's in the 2.5D module. It's just added in. It's not in a particular module. It's everywhere throughout. So I'm just going to quickly have a look at that. In fact, if I was to just quickly show you my other screen where we've got the strategy on there. If I show you a couple of slides here, what we've got in the mirror transform, you can transform operations within on the same part. As you can see on the graphic there, you've got a part that's got a mirror version of certain features. It's a symmetrical part, so you can machine certain features and then mirror them over a plane or a selected coordinate system. So you could have a coordinate system, as you can see in the graphic here, or a plane that you've created on there in the center of the part, and just mirror the features across from one side to the other. If there isn't, if you want to do it across a coordinate and the coordinate isn't there, it'll create a coordinate for you. So perhaps your coordinate might be on the second side. And also, yeah, you can mirror it across a plane onto it. Well, this is the same part, but you can use it for separate parts. That's sort of what I'm going to show you in a second. Where am I? Come on. Oh, where's my? There we go. Sorry, I got lost for a second. It's too many screens. Right, let's have a look at our part then in SolidCAM that we're going to mirror. Here we go. This is how I think it might be used, it's most efficient, if you like. You can mirror features on parts, as you've just seen on the graphic, but you can also mirror features across onto a different part. So this is a typical example that you may want to use. It's a simple part. This obviously, this is actually a left and right hand version of the same part in two different vices. It's actually the same part upside down. If I was to turn that upside down, you can see it's actually the same part upside down. So if you have something similar to this that you may want to work on, obviously this is very simple. It probably wouldn't take you much time to actually machine it anyway, but if it was a complex part, a really complex part with lots and lots of toolpath that you were wanting to mirror, to make a left-hand version of, such as an automotive part or an aerospace part or something like that, you may want to mirror the whole lot to make a left-hand version of it and apply it to another model. It's not as straightforward as that. It's the way this works is the idea about mirroring is that you've got to mirror it about something. You've got to mirror it about a point or a plane or something. So what I've done here, I've got two coordinate systems here. I've got the coordinate system for my part. This is the part on the right hand side that I'm actually going to machine and apply the toolpath to. Then I'm going to apply that toolpath and mirror that toolpath to this part over on the left hand side. And I've created a second coordinate position, a second coordinate itself, Mach 2 position, in the center, in the middle between the two. So that's our axis point. So this point here has got to be exactly in the middle between that point and that point. However, I know you're not going to work that way. You don't know on your machine bed exactly where these two vices are going to be plonked, unless you happen to have them permanently set up like that, and you do know that value. The guy on the machine might not have these on the table when you come to program it, so you don't know how far apart he's going to actually set these up. What you can do, here's our original toolpath on this right hand part here, and how you mirror it. Let me just I'll suppress these two features here for now. Where's my menu? Why wouldn't it let me suppress them both together? Don't know. Okay, I'll suppress them two features there. So we've just got our original toolpath showing. Now if I want to mirror that toolpath over to this side, it's a simple matter of right clicking. We've got mirror here now. It's a separate thing. It's not, you've got mirror within the transform, but we've got a separate mirroring function here as well. And the mirroring function looks slightly different from previous. We're going to add an operation here. It's a single operation as it happens, but it could be multiple operations. I could have highlighted, a whole raft of operations there if I had them. But for the demonstration purposes, I'm just keeping it to the simple one operation. We can add a new operation at the end of the current position in the operations tree, or add it at the end of the operations tree itself, which is the same thing in my case because there's only one. So that's familiar from previous, but now we've got mirroring about point. We can mirror about either a plane or a coordinate. So let's have a look at the plane, for instance. So I've got a plane. We can choose a selected plane. So I choose the selected plane button, and now we need to know where's this plane. Well, I created a plane earlier in the SolidWorks plane, and it's here, plane 1. So I'm going to mirror about that plane. Okay, and you can see as soon as I've selected that, it's showing me here is my toolpath presented exactly equidistant on the other side of that plane onto my new part. So far so good. Click OK, and there it is. There's my toolpath on the other side of the plane. The thing about this is, though, that's slightly different, well, a lot different to the previous plane mirroring operation that was included in transform, is that this time it's keeping its climb milling direction. It's setting climb milling direction on the right hand part, and it's now still climb milling on the other side. So if I was to simulate that on the original part, you can see that it's trying to go too fast, but hopefully you'll be able to see that. It's climb milling, and you can see it's climb milling on the second side. The only thing with the second part is we can't apply the stock to it, as you can see on the right hand side. It's not that advanced that you can show two pieces of stock. Having said that, I'm sure this mirror will be developed in future versions of SolidCAM, so we can we'll keep an eye on it and make you aware of any advances that are made in that. The one thing to know, I'll just mirror this also. Apart from mirroring it about the plane, I can mirror it about a coordinate system. So in the ZX plane, I can mirror it about itself, or I can mirror it about my second Mac position. So that's my initial position. I've mirrored it about itself to the left there, or I can, as I said, I've got a Mac position in the center here. I can select that and mirror it about that point and mirror it onto the part also. So I get the same result as I did when I mirrored it about the plane. The one thing to notice though is that your second part is still in relation to the Mach 1 position. You can't sort of have it related to a completely separate coordinate, as you would have, say, perhaps the right vice might be your G54, your left vice might be your G55. It doesn't work that way. You can't sort of refer that to a second coordinate. As I say, this is the first version of this new feature that we've included in 16. So I dare say it'll be constantly looked at and developed. However, if you do want to work the way that I've just suggested, where you have one part as your G54 and the other part as your G55 perhaps, we can work that way. You just need to let us know that's what you want to do. And if you've got the post-maintenance that we always encourage you to take out, then we can modify your post for a new way of working, obviously FOC, free of charge, and keep you working in the way that you want to work. Okay, so that's the new feature for the mirroring feature. Let me just flip you back to my other screen again, because on that other screen, as I mentioned earlier, I've got one final slide to show you, and that's about the one-day training course, update training course for 2016. If you're interested in this and availability and pricing for that, please contact Louise on the number given there, 01226 241 744, or you can email Louise at louise@solidcamuk.com and get on some of these courses. These courses, of course, aren't just exclusively for what's new in 2016. We can consider this as some sort of an update training overall. You know, if you've been used to using SolidCAM 2014 and you didn't upgrade to 15, you might have missed all the upgrades that were included in 15. So it's a bit of bringing you up to date, really, as to what's new and what all the changes that's been made in SolidCAM. Okay, well, that sort of brings me to the end of the webinar, really. So I'll just have a quick wait. I'll leave this slide up if any of you guys have got any questions on what you've just seen today, or anything else for that matter. No one's asked me a question so far. I can't see anything that's particularly been asked. The one thing that you may want to ask is when can I have it? The answer to that is give us a call. It's going to be generally released to everybody sometime next month in October. We did hope that it was going to be released a little bit earlier than that, but it looks like it's going to be sometime in October. However, customers of ours who have attended this webinar will be able to have it sent directly to them as a pre-release version. Now that you understand the changes and what have you that have been made in SolidCAM 2016. So if you would like to get your hands on on 16, and you like what you've seen, please give us a call at the office. Contact us. Contact me by email. Contact Louise by email, and we can sort you out. Okay. Well, nobody's asked a question, so I'm assuming everyone's happy with what they've seen. And to that end, I shall say goodbye and wish you all a nice weekend. And see you next time. Thank you very much for attending. Bye-bye.